In this problem, we're given the heights of winning presidential candidates and their main opponents from several recent presidential elections. So first we want to find the regression equation, letting president be the predictor variable. So that is, those data values are going to go into list 1 in the calculator. And then the opponent is the response variable, and we'll put that into list 2. So I've taken this data and I've put it into lists 1 and 2 in the calculator. And then I'm going to click Stat and go over to Calculate and choose number 8, which is linear regression A plus BX, because that's the format that they give in the homework question. So when I choose that, my X list is L1 and my Y list is L2. So then I'm going to go ahead and calculate, and I'll get my result. And I've got that right here. So for now, we're looking for the regression equation. So that's going to be y hat equals 147. It's said to round to the nearest integer for the y-intercept, plus 0.174 for the slope, because we're rounding that to 3 places. So that's the equation of the regression line. And we put that in and we'll see that that is the correct equation. Okay, so now we're ready for part 2. Now we want to find the best predicted height of an opponent given that the president had a height of 188 centimeters. So here's what I do at this point. I'm going to make a number line for the value of the correlation coefficient. And that value can range anywhere from -1 to 1. If it's close to 0, then we are going to say that there is not a strong linear relationship. And if it's close to positive or -1, then we're going to say that there is a strong linear relationship. So here we have our correlation coefficient R, and that is 0.178. So they don't give us a cutoff for what is close to 0 and what is close to 1. But we can see in this case, this is pretty close to 0. So I'm going to say that our regression equation is not a good model. For this data. So if the regression equation is not a good model for this data, then what I do is I find the mean of the y values. So that was list 2. Those are my y values. And I'm going to find out what is y bar, and that's the value that I'm going to make my best predicted height. So how do I find y bar? So what I did, I already have my data in L2, so I did 1 var stats for L2. And the x bar, which is really y bar in this case, is 179.2. So that's going to be my best prediction because the equation is not going to give me a good prediction. So we go ahead and put that in for our best predicted height, and that is the correct value. So we've got that best value there. And then we want to know how close is the result to the actual opponent height of 175 centimeters. So our value was 179.2. That is not exactly the same, so we can't choose that. Is it more than 5 centimeters less than the actual? No, because that would be 170 or less, and that's not correct. Is it within 5 centimeters? Yes, it is. So that's our final answer for that particular question. Now let's take a look at what would you do if the regression equation was a good fit for the data. Now let's take a look at this question. Here we're comparing foot length to height. So what I did in my calculator is I put foot length into L3 and height into L4. And then I found my regression equation the same way I did with the previous set of data. So in this case, our regression equation, or our line of best fit, is going to be y hat equals 346 for the y-intercept plus 5.22. They want us to round the slope to 2 decimal places, so that's correct, times x. So that's what we're going to put in for our regression equation. Okay, so now let's take a look at part 2. It says the best predicted height of a male with a foot length of 273.2 millimeters is what? So again, I'm going to draw my number line. And I look at where my correlation coefficient falls on this number line. So in this case, it's going to fall pretty close to the top here, 0.8596. We'll call it that. Now, you do have a list of critical values of R. They don't ask you to actually use that list, but I could, and I'll see in either case that this, whether we're using alpha equals 0.05 or alpha equals 0.01, that this value is close to 1 for our correlation coefficient. So that means that the regression equation is a good model for this data. So we want to use the regression equation, and we're going to plug in 273.2 for x. And calculate that best predicted height. And here I got 1,772, and it said to round to the nearest integer, so that's what I would put in there. And then finally, it asks, how does that result compare to the actual height of 1,776 millimeters? So we're off by 4 millimeters, and we're talking about the heights of people. So it's very close. So we can say the result is close to the actual height of 1,776. And they don't give us a definition of what would be close and what would not be, but you can use your common sense in this case to say that that result would be close. And that's how you do that problem, or both of those problems.